shortly after Dr. Rashid dropped his question, yeah, I think I had a technical issue here. We're on the same network with some other guy here, and we are on, but I was disconnected. We'll look into that. Anyway, so to go into your questions, Doctor, you see, yeah, you have made a lot of very good one, and I hope, I'm not sure if there is a research group on this idea, peace, conflict, and its solution. Doctor, you may have to think of maybe creating a research group under our research collaboration groups, and then maybe share the link so that people can join. I believe, like I said, peace, conflicts, disaster, and all these kind of areas, everybody should be more interested in it. How can we build AI system that can prevent it? And when it happens, can we speed it up? You raise a lot of very important issues. How can we prevent terrorism funding from the cryptocurrency point of view? So these are very, very nice ideas. And then mistargeting is still a common thing, even all over the world. So even locally, we've had cases like that. However, there is need for deployment of infrastructure, because it is still better to let a criminal escape than killing an innocent person. Life is precious, sacrosanct. So effort need to be made to reduce collateral damage as much as possible. So the system need to be built that drone can be flew as low as possible. There are drones that can fly as close as your top head, and you will never see it because of the nature of the color. It tells the color of the environment. So you don't even know there's a drone that is flying there, and it can take a very close video of the event to really know, are these people civilians or they are criminals planning planning disaster. Not just because we're just looking at some very cloudy people moving, and we think they are criminals, and then we launch attack on them, only to find out that these are just children, these are innocent people going about their normal activity. This shouldn't happen. So I want to believe it's something that is doable, but it needs a lot of infrastructural upliftment. Military personnel, military settings need to be enhanced, provide the needed technology that can support this. But with AI, I want to believe, if well enhanced and if well harnessed, can go a long way to preventing such missed targets. So, or at least reduce it to the barest minimum. Now, to your question, when you have data set, 77 data set, it's a very still small data, but however, you can model with it. But the only problem is task imbalance. The imbalance is much, 69 against 8, only 8 negative. You see? So hopefully in future data collection, we can expedite it and make sure we get more. But as it is, we can work with it. First of all, run the model as it is. 8 is still sizable. And for such data set, you can do cross validation. The data is not much. You can do cross validation, and you may also do the percentage split. It doesn't matter. If you are the first one to work on this work, you can select whatever you feel like. Use 30-70 or use 80-20. You see, 80-20 is fine. 70-30 is fine. So whatever you settle for, you are the first one, but whatever you use, subsequent researcher will have to reference your own as the way to start. So, however, for this kind of few data set, and one of the areas you will recommend to use the cross validation is when the data is filled. Oh, this is fitting precisely well with it. You can use cross validation for a start, and then try partitioning into testing and training is not bad. So it's always option. You can run the two and put the results side by side later, and then discuss. However, since the data is imbalanced, there are two ways of balancing data. We have when you want to balance data, your data set is having 77, out of which 68 is positive, 69 is positive, and 8 negative. So you first run the experiment as it is in balanced data. 2, you go to undersampling may not be advisable because the data is too much. Undersampling, these are 2 ways of balancing data. Undersampling means you reduce this majority to become 8. So you have 8 against 8. These are going to be 16 data. You can still use cross-validation, twofold for it, and see what you get, but it's very small data, but you can still use it. However, the one that may likely work for you is the oversampling. Oversampling. In the oversampling techniques, what you do is we have a popular method called smooth in Weka. You can use this in Weka. You can also, in your Excel, do it. It means we have 69 positive. You increase this 8 randomly until it becomes, you keep copy-pasting this 8. Increase it, repeat the number until it becomes also 69 or 70. It's close together, that's fine. Or 68 or 64. Because when you say balanced data, it doesn't mean they have to be equal in number. It doesn't mean 69, 69. You see? Because, yeah. And if you are making 69, 69, that's fine. This is called balanced data. However, the right way to do it, people do it this way. 69, 69, now they divide it into 2. Training and testing. Or you use cross-validation on it and see what you can get. However, in the normal setting, the correct thing to do is you divide your data into 2, training and testing, before you only oversample the training set. The testing set, for example, you can have like maybe out of 69, you allocated like maybe 15 for testing in the positive side, and you allocate like out of 8, you allocate like 3 for testing. This is the testing set. You leave it like that. You don't oversample testing set, because in real world, where you're going to use the data there is not oversampled. So here, you now have like maybe now you have like a 44 against 5. This is when you are going to oversample. You increase this 5 until you get 44 against 44. That is, now you train your model with this, especially if you want to use division, partition into training and testing set method. You do it this way, and then you can see what you are going to get. But if you want to do cross-validation, then that is fine. Just balance everything as you have, 69, 69, and run cross-validation on them and see what result you are getting. So this is the way you do oversampling when you have very imbalanced data like this. And I want to believe one of our videos I already discussed how to do oversampling. So you can check it out. And if you're not there,